Day 162, Honors Physics, Photoelectric Effect, problem number 25. I will take the shortcut in this problem, like I've been talking about and I've done a couple times before. Once again, if you take your two standard equations, V equals lambda F for a wave, for a photon, or any wave, and E equals HF, the energy of a photon, solve this for F equals V over lambda. Solve V over lambda in over here for F. You get the energy of a photon is Planck's constant times the velocity of light, of photons, divided by the wavelength. In this case, they give you two different wavelengths. So we'll figure out both of those. I call them E sub 1 and E sub 2. So I'm finding out the energy of the first photons. It says the threshold is 260 nanometers. That's my wavelength, 260 times 10 to the negative ninth. This will come out in joules because I'm using the joule version of Planck's constant, and our constant speed of light is 3 times 10 to the 8th. So E sub 1 will come out in joules. Write that down. And likewise, I'm going to change the 260 to 135, which is half as big. So E sub 2 will come out almost twice as big as E sub 1. Not quite, but that will also come out in joules. Let's make some sense out of this now. All right, E sub 1, it says, is the threshold wavelength for this gold electrode. So that is the work function for gold. Actually, we could have looked that up, but hopefully it's close to 4.82. That's what it says in the chart, but we're not assuming we're using a chart this time. It says to use that as the threshold. I'm hoping it's close to 4.82. Well, we were in joules, so you'd have to double check that to see how many electron volts that is. I'm not even going to bother right now, but if you want to check that, you may. But that will be the threshold in joules for this gold plate or gold metal. Now it says we're hitting this actual gold plate with ultraviolet, which is higher energy, almost twice the energy of the work function. So that will be the incoming photons that are striking the gold plate. So I know two of the three numbers over here then in the photoelectric effect equation, which will allow me to get the kinetic energy in joules. I'm plugging everything in joules. These are in joules, these are in joules. So this will come out in joules, and that'll be the number you bring down here, which will then go in there. So that will be the last step. So bottom line is you can take E sub 2 minus E sub 1. That'll give you the kinetic energy. And then just plug into the kinetic energy formula, 1/2 mv squared. Solve for V. Once again, don't forget to take the square root at the end there as your final step.